Okay, you might want to take out a piece of paper so that you can copy down some notes if you chose not to print out these notes. So today we're going to talk about medians and centroids. So the first thing that you need to know is that a median, it's a vocabulary word, is a segment drawn from a vertex or an angle to the midpoint of the opposite side. So here's our vertex, and this right here is our midpoint. So again, a median goes to the midpoint of the opposite side. Now, a centroid is the point in a triangle where all three medians meet, and it's called the point of concurrency. It's where all three medians meet. Another vocabulary word that you might want to write down. So the point where the medians are concurrent is called the centroid of a triangle. And if we look at these two examples, the median of an acute triangle, it's right here. This is our centroid. And the medians of an obtuse triangle, again, it is right there where all three medians meet. Again, that is called the centroid. So what we need to know for our class is that a centroid divides the medians into a 2-to-1 ratio. So again, when you see the word ratio, you should think that really means 2x and 1x. One of the pieces is twice as long as the other. The section of the median nearest the vertex is twice as long as the section near the midpoint of the triangle side, which means if this here is my centroid, and if I focus on this median, I know that from here to here has a length of 2x because it's going to be twice as long as the piece from here to here. That would be 1x or x. If I look at another median, again, going from the angle to the centroid has a length of 2x, and then from the centroid to the side has a length of x. So this piece here is twice as long as this one. If we only have one median drawn, again, the ratio here from A to G, so from A to G is 2x, and the length from G to D is equal to 1x. It's a ratio of 2-to-1. So this piece here is twice as long as this piece here. So now we're going to apply that to some regions questions that we've seen in the past. The first one says triangle ABC is graphed on the set of axes below. It says what are the coordinates of the point of intersection of the medians of triangle ABC? So we know medians go to midpoints. So the first thing I'm going to do is count my boxes from B to C. 1, 2, 3, 4, 5, 6. Half of 6, or the middle of 6, is 3. So I know that my median has to be somewhere, has to go from A to this point. Now I'm going to try to find the midpoints of the other two sides. So if I look at A, 1, 2, 3, 4, those coordinates are 1, 2, 3, 4, 5, negative 5, 2. The coordinates of B are 1, 5. So if I wanted to find the midpoint there, I'm going to add my x's together, divide by 2. I'm going to add my y's together, and I'm going to divide by 2. So that's negative 4 over 2, which is negative 2. 7 over 2, which is 3.5. So I'm going to go back 2, up 1, 2, 3 and a half. This is the midpoint, so I'm going to connect there. And then if I find the midpoint between A and C, C is 1, negative 1. So if I find the midpoint between these two, negative 5 plus 1 over 2, 2 plus negative 1 over 2. This becomes negative 4 over 2, which is negative 2. 1 over 2. So my midpoint for A to C is negative 2, 1/2, which is right there. And again, if I connect that to the opposite vertex, if I look at my picture, right here is where my medians all cross each other, and that is at negative 1 up 2, so that's this point here. Now, sometimes they give you more algebraic questions. So this one says, in the diagram below of triangle ACE, medians AD, EB, and CF intersect at G, that tells me that G is a centroid. Now it tells me the length of FG is 12. So we want to write a little 12 from F to G. And it says, what is the length in centimeters of G to C? So I want to find the length of G to C. If I notice, this is from the angle to the centroid. That has to be twice the measure from the centroid to the opposite side. So we're just going to double the 12, and we get 24. Again, that is our magic ratio of 2x to 1x. So if x is 12, 2x is 24. Now, if we look at this diagram of triangle ABC, again, it tells us that we have medians. Now, it tells us that the length of CF, so CF, this whole entire piece here, is 24. It says, what is the length of FG? So I want to find the length of FG. Now again, because I have intersecting medians, the rule is from the angle to the centroid is twice as long from the centroid to the opposite side. So if I look at what I wrote there, I can make a nice little equation of 2x plus x equals 24. 3x is 24. If I solve, I get x is 8. And I need to go back and look at the question. It's asking me to find the length of F to G, so this piece here, which is just x, so x is 8. And the last one that we need to do, again, it tells us that we have medians, AD, BE, and CF, and they all intersect at R. So point R is, again, our centroid. Now it tells me that CR is 24, so I would mark my picture. CR is 24. And it says RF, so we'll pick a different color here, is 2x minus 6. So again, if I go back to my ratio rule, it says from the angle to the centroid is twice as long as this. So if I wanted to write an equation, I can say that the 24 is, so equals, 2 of RFs. So if I solve there, 24 equals 4x minus 12. If I add 12, I get 36 equals 4x. If I divide both sides by 4, I get x is 9. Some kids might use that method to solve, and it says the value of x, which is 9. Other kids might see it that the 2x minus 6 piece, the R to F, is half of the other piece, CR, so half of 24. So here, if I solve this one, I get 2x minus 6 equals 12. If I solve, 2x equals 18. If I divide by 2, once again, x is 9. I don't care which way you solve it. Either way, you'll see that you get x is 9. The most important thing to remember when you're doing these types of problems is that the part from the angle to the centroid is always twice as long as the part from the centroid to the opposite side. Please make sure that you write down any questions that you might have and either email me or ask me next time you see me in class.